Hello everyone, welcome to my channel Mathematica, and this is the another video of CSIR Net Mathematical Science Problems and Solutions. And our today's problem is from CSIR Net December 2023, and our question ID is 704047. This problem is from integral equation, and our given problem is the value of lambda for which the integral equation yx equal to lambda 0 to 1 x square e to the power x plus t y t dt has a non-zero solution. So we have to find the value of lambda such that this integral equation has a non-zero solution. Actually, we have to find the eigenvalue. Lambda is the eigenvalue here. So we have to find the eigenvalue such that the non-zero solution, the integral equation has a non-zero solution. This is the eigenfunction. The solution will be the eigenfunction. So since this is the Friedel integral equation, at first we write the integral equations again. 0 to 1 x square e to the power x plus t yt dt. This is the kernel. Look, this kernel is a separable kernel. Separable kernels means the kernel kxt, which can be expressed as a function of x and into a function of t, if I gi. I runs from 1 to n. This type of kernel is called separable kernel. Here the kernel is kxt is x square e to the power x plus t. This can be written as x square e to the power x into e to the power t. So this is the f1x and this is the f1 g1t. So this kernel is a separable kernel. Now we can write this, since the integration with respect to t, so we can take the value x square e to the power x, the variable x square e to the power x from the outside of the integration. That is 0 to 1 e to the power t yt dt. Let us put this c. Since this is a finite integral, definite integral, so we can write it c. Lambda x square e to the power x into c, where c equal to 0 to 1 e to the power t yt dt. Now, what are yt? Our y is c lambda x square e to the power x. So we can put the value of yx here, then can integrate 0 to 1 e to the power t. Yt means lambda t square e to the power t into c. Therefore, c equal to lambda c 0 to 1, sorry, it will be e to the power t, e to the power 2t, t square e to the power 2t dt. So we can integrate it easily. Lambda c, we can use the method of by parts integration. So this will becomes lambda c t square e to the power 2t by 2, limit is 0 to 1, and integration 0 to 1, derivative of the first function, that is 2t, and integration of the second function e to the power 2t by 2 dt. So this will be lambda c. This becomes e square by 2 minus, which can be written as, this is again we can integrate by parts. So t e to the power 2t by 2, which is limit is 0 to 1, and integration 0 to 1, derivative of the first function, derivative, that is derivative of t, which is 1. So e to the power 2t by 2 dt. So lambda c. So here we also get e square by 2, and this e square by 2 and e square by 2 will be cancelled out. So our result becomes, and minus, in this minus will be plus. So 0 to 1 e to the power 2t by 2 dt, which is lambda c e to the power 2t by 4, 0 to 1. So lambda c by 4, and this becomes e square minus 1. Putting t equal to 1, which will be e square, and putting t equal to 0, e to the power 0 will be 1. So what we get? We get here that c equal to lambda c e square minus 1 by 4. So we can write c into 1 minus lambda e square minus 1 by 4 equal to 0. Now, there are two possibilities. Either c equal to 0 or this will be equal to 0. If c equal to 0, putting in y, we get yx equal to 0. This is a trivial solution which cannot be the eigenfunction. So c must be non-zero. So otherwise we get 1 equal to lambda e square minus 1 by 4. Therefore, we get lambda equal to 4 by e square minus 1. This is our eigenvalue. So our option C is right.